Hello everyone. In this video we are going to use Excel in order to help us do a one sample hypothesis testing for means. Let's look at our scenario. Jordan is doing research for a hospital system that has adopted a new form of hip replacement. She has been tasked to see if patients undergoing this new form of hip replacement have a faster recovery time than patients undergoing a standard hip replacement. She knows from many years of records the average amount of time to recovery for a standard hip replacement is 39.12 days. Jordan then randomly selects patients at her hospitals undergoing this new surgery and measures their respective time to recovery. She wishes to conduct her research at the significance level of 0.05. Okay, so first things first, let's go ahead and just grab our data and let's copy it into Excel. Copy, and let's paste it in. And we have all of these days to recovery. Now let's go ahead and select it again. So I'm going to click on this first one, do Control Shift down. And what I'm going to do is do Control M. Let's get some descriptive statistics and normality. We don't need box plots or the Shapiro-Wilk. Because I have a title here, be sure to include this checkbox here for the column headings included with the data. And let's tell it where to put our summary statistics. And we can just go ahead and click. All right, so here I have my mean days to recovery time that we saw. We have our median, we have our standard deviations. We've got a whole bunch of good information here. Before we move on, let's go ahead and grab a couple of pieces of information that were provided to us. So we know that the hypothesized mean value, or mu naught, is equal to this 39.12 days. This is like the baseline that we are comparing our results to. So we have that, and we were also provided with alpha, or the significance level, which was just 0.05. And if we have alpha, we also have the confidence level, because we know that the confidence level is just 1 minus alpha. Okay, so we were able to get all of that from right at the beginning. And now let's go ahead and answer some of our preliminary questions. So the type of data that we are dealing with here is numerical numbers, and we're wishing to look at the mean. The distribution that we should be using is our t-distribution, and this boils down to basically what type of standard deviation do we have. Did our original problem give us a population standard deviation? It didn't. Then what we have to use is the sample standard deviation, which requires us to use the t-distribution. And if we're using the t-distribution, this is the particular equation that we are going to be using for one sample hypothesis testing, which is this x bar minus mu naught divided by s, which is our sample standard deviation, divided by the square root of n. And remember, everything that's in the denominator here is known as our standard error. The population of interest are the hip patients in Jordan's hospital system. That's who we're interested in, is who's going to have this recovery time. The parameter of interest that we want to know more about is the true mean recovery time. And is our sample sufficiently large really boils down to how big our sample size is. Remember the central limit theorem, if the original distribution says, or the original problem says nothing about the original distribution, is that we need to have a minimum sample size of 30 in order to invoke the central limit theorem. And we do. We have a sample size of 52, so that we know that our sampling distribution, or the distribution of our means, is going to be approximately normally distributed around the true mean. So let's go ahead and keep on going. All right, so now we need to establish our null and our alternative hypothesis. So the cool thing about these is they are identical except for the inequalities, or this middle part. So because we're dealing with numerical data and we're testing means, we want to have mu here. And the null hypothesis is always going to be equal, and we set it equal to the baseline assumption here of what our mu naught was, which is 39.12. So I'm going to put that in. 39.12 is our hypothesized mean. So we're going to have 39.12 here again. And now we just need to know, is it going to be less than, greater than, or not equal to? And if we go up here, we can know which direction we want to go from our problem. And because she's interested in this new form of hip replacements having a faster recovery time, that means that we think that the true recovery time is going to be less than the standard hip replacement time. So we want to put in a less than symbol here for our null hypothesis. We've already identified our alpha as 0.05, and now we can go through and do these. So x bar is going to be the number of days on average from this new hip replacement methodology, and ours is 34.37. So that we get our 34.365. Our sample size is going to be 52. Our standard deviation here is this 9.57. And then our standard error. And remember, our standard error is just the sample standard deviation divided by the square root of n. Now, we can do that, or if you notice that Excel has already provided it for you, this 1.32786. So the next thing that we need to do is determine the test statistic and the p-value. So our test statistic here is asking us for two numbers. Because we're doing a t, we need to know what our degrees of freedom are. And the degrees of freedom for a one sample hypothesis test are quite simple. It's just equal to the sample size, 52, minus 1. And so I have 51 as my sample size. And now I need my t, actually calculate out this t-value. And to do that, I need to use this equation that I just selected up here. So I know that my t is going to be equal to, or my t-score, call it my t-score, is equal to x bar minus mu naught divided by the standard error. And we can do that. That's not too bad. Say equals x bar, that's our sample mean, minus mu naught, our hypothesized mean, and we're going to divide by the standard error. That provides us our t-score. So we have our t-score here. Let's go down, we'll look at it. It's negative 3.5. And we now need our p-value. So in order to get our p-value, what we're going to do is we're going to do t.dist, and it's asking for x here. X is just what did we calculate for our t-score, which was this t-value, comma, it's asking for the degrees of freedom. Click on our 51. And then we do want the cumulative, and so we're going to say true, T-R-U-E, and then hit enter. And this is our p-value. It's 0.00038. It's very, very small. And when we compare our p-value to our alpha, we know that it is less than. Our confidence interval, we can use the same equations that we have done before, and let's pull one of those out real quick. So we know that the lower end is going to be negative infinity because we're doing a one-tailed confidence interval, because our alternative hypothesis is less than. Okay, so because it's less than, we just need to know the confidence interval upper. So remember, confidence interval upper is going to look like this. It's our x bar plus a t-crit times our standard error. So let's do that real quick. We have that as equal. Oh, first of all, we need our t-critical. So t-crit is going to be equal to this real quick. We've done this before. Absolute value, t dot inverse. We need our probability, which is just going to be alpha. We're not dividing it by 2 because this is a one-tailed confidence interval. And we need our degrees of freedom again, which are 51. And now we have our t-crit. Now that we've got our t-crit, we can say equals that our x bar, our sample mean, plus t-critical times the standard error, that guy, is equal to 36.56 essentially. And let's go look at that. 36.5899, that's what we've got. We are going to reject the null hypothesis because the hypothesized value of 39 does not fall inside of this confidence interval. And so we can say that we have collected sufficient evidence, and this is how we reported in APA, t degrees of freedom and what we got for the t-score, the respective p-value that we got, and the alpha, to reject the claim that the true mean recovery time is equal to 39.12 days, and instead claim that it is less than that. Now we do our confidence interval part. Say we are 95% confident that the true mean recovery time is in fact somewhere between negative infinity and 36.59 days, or else we could also say that we're 95% confident that it is no more than 36.59 days. So that's how we do it by hand. I will post another video to show how we can use some Excel templates to help speed up this process. Good luck on your own problems.